to SQL Bits 2020. This is actually my first SQL Bits. I was hoping to be there in person, but anyway, I'm happy to meet you all virtually. My name is Umachandar. I am a program manager in the SQL Server team. I worked on big data clusters for SQL Server 2019 release. Before that, I worked on machine learning services and other features in this engine. So today I'm going to talk to you about Azure Arc data services. So let's get going. Okay, so this is the agenda I have for today. I'll do a quick introduction on Azure Arc, and then we'll cover what data services comprise in the Azure Arc environment. Then we look at some key aspects of data services like deployment, security, and HA. My goals for this session are the following. So hopefully at the end of the session, you will have an idea of what is Azure Arc, what it can do for you. Similarly, what is Azure Arc data services? And if you're an administrator or a developer, what does it mean to use data services, right? And then you learn some new ways to use database instances in this environment. Okay, to set some context for why Azure Arc, it all starts with the hybrid cloud world. Here is the survey from RightScale, and in this survey, 85% of the respondents said like they are using a hybrid cloud strategy, right? So that means they have both a private and a public cloud environment. They are running applications in their data center in the cloud. And the trend continues, and the same thing applies in 2019 also, right? And this pattern is not really changing anytime. So what does it mean, right? So this means you now have applications which are deployed in many environments. They are very diversely, deployed in the sense you have the apps deployed in data centers. It's in your edge device. Applications running in virtual machines. You have some apps running as code in the cloud, right? Um, so there is a very complex environment, diverse environment, and basically, how do you uh, now think about this, right? So this is where Azure Arc comes into play. So this is about bringing the Azure services and management to any infrastructure. And today we look at how data services fits in this environment and how you can run it anywhere. So some of the key pillars for Azure Arc is that it extends the Azure control plane over to your environment. Whether it's your data center, your edge device, your VMs, your bare metal machines. I mean, it's about using the Azure control plane and resource manager to look at these resources, manage them in a unified way. It's as if those resources were actually provisioned in the cloud, right? So by bringing the Azure control plane to your infrastructure, you can now benefit from many of the cloud innovations. For example, the security, right? So we can run agents which look at your infrastructure, applications, services, and flag security issues, right? You can establish policies for your updates. You can do backups and so on. So this is what Azure Arc is about. It's bringing the Azure control plane, your resource manager, and extending it to your infrastructure. So now you get a unified view of all your applications, your infrastructure in a single place. So let's kind of look at what this means. So now up there you have the Azure control plane here, and you have different infrastructure. So one of the ways is like, say today, for example, you can install Azure Stack HCI, and you can similarly on your Azure Stack Hub or Edge device, you can install your VM, right? And now you can connect, say, your Azure Stack HCI up to Azure, right? Um, Now you can do the same with any server, whether it's your Windows server, Linux server, your SQL Server instances, and project them up to Azure. So that means they show in the portal as any other resource in Azure, and you can take certain actions on it. And this applies the same even if your server or SQL Server are deployed in other cloud platforms, right? So install an agent and then you can connect it up to Azure. Now you can also have Kubernetes on this environment, whether it's your own data center or it's your cloud environment with the cloud Kubernetes offering. And the Kubernetes clusters can also be connected to Azure. And the same thing you can do for AKS on Azure Stack or your VMs. Now this is where your SQL managed instance and Postgres hyperscale fit in, is we deploy it on top of your Kubernetes environment. Whether it's in your infrastructure or it's in the Azure Stack kind of infrastructure or another cloud provider, you can basically connect all of this up to Azure. And this kind of the complete picture. So if you have an environment which kind of falls into all of these categories, I mean, you just look at it the same way, right? And now once they're connected up to Azure, you can leverage Azure AD. You can set up backup policies. You can monitor them. You can analyze your logs and so on, right? So this is kind of what Azure Arc is about. Now we'll look at Azure Arc Data Services, what it means to run data services in your infrastructure. So one of the key things is like, how do you stay current always, right? This is a challenge. Like, how do you update your database instances? Can you do it in a very efficient manner with minimal downtime? Can the updates be automated? So you schedule a maintenance window and the updates automatically happen for you, right? So these are capabilities we will provide with the data services. And in case of SQL, we'll also have this evergreen SQL instance. It's like the SQL PaaS offering, right? And then elastic scale. I mean, since we can leverage many of the Kubernetes capabilities, we can actually provide ways to scale up the resources for your instance. You can scale out your Postgres hyperscale instances. You can have HA enabled easily, right? And you can also do automation at scale. Say you want to deploy 100 managed instances. I mean, you can do that now. And the last thing is about unified management. Like once these services are deployed and you basically use the same tool sets, same workflow, you leverage the same monitoring capabilities, and you can uh, look at it the same way, right? And all of this kind of works both in the connected and the disconnected environment. And this is one of the key requirements for us. I mean, we have from customers who have air-gapped environments, and we want to be able to support those with data services. Now we look at some of the capabilities in SQL managed instance with respect to other offerings. So in this table, we are basically looking at three offerings like the SQL Server, which is your standalone SQL instance, the SQL managed instance, which is deployed in Azure Arc, and your managed instance up in the cloud, right, in Azure. So let's highlight few things here. So in terms of scalability, uh, we can leverage the Kubernetes capabilities and your infrastructure. And this provides a way for you to scale your managed instance in a very seamless manner, right? Say you want to increase the number of cores for your managed instance. It's just a simple command, a kubernetes command or a AZ data command, and you can just increase it. Same you can do in the SQL managed instance. So in that sense, like you kind of have the same capabilities. Similarly, ability to do HA and DR will be automatically enabled based on the capabilities in your environment, right? And these are basically some abilities like which are automatically enabled, and you don't need to worry about how to configure it, manage it, and so on, right? And then the whole aspect of who manages it, what are the SLAs. With SQL Server, you are doing all of the management, and the same thing applies for the Azure Arc Data Services. I mean, it's your environment, so we will handle the software part for you. Um, but in terms of SLA, I mean, you need to ensure that your systems are up and running always. You have, protection for your hardware in terms of storage and so on, right? So these are kind of some key differences. Now the same thing applies to the PostgreSQL hyperscale also. And one of the things in terms of elastic scale is again you can do the same scaling of the Postgres instances, and this is again only limited by the capacity in your Kubernetes cluster. Same with the HA capabilities. So now let's look at what it means to use data services, right? Say you are a DBA or a cluster administrator. How can you leverage Azure Arc Data Services? And also the other question which often comes up is like, hey, I mean, what do I need to know, right? Like, I mean, what are the new things I need to learn or adopt? So let's first look at the platform requirements. So the entire Azure Arc Data Services is deployed on top of Kubernetes cluster. So this is something from an infrastructure standpoint you need, right? So this is a new requirement. You may have an existing Kubernetes cluster which you can leverage, but this is something which is a fundamental requirement. And in all of the data services, they're all based on Linux containers. So that means you need to be able to manage them, maybe debug certain things there. So it's all Linux. And then storage again is managed at a cluster level, right? The Kubernetes cluster level. So this is a kind of fundamental difference. And then what about deployment options, right? So we will have CLI experience either through our AZ data or AZ CLI or the Kubernetes CLI. So this is one standard way to deploy all of these services. Then there'll be other ways to integrate the deployment with, say, your GitHub's workflow, right? And then we'll have the UI capabilities from either the portal or your Azure Data Studio. And lastly, as part of the deployment, you can actually set up your updates also, right? Like, so you can say, hey, this is how my schedule for my automatic updates, and that's what I want to enforce, right? So these are capabilities which will be enabled for administrators. And then lastly, in terms of resource management, you can now leverage the Kubernetes resource manager to set limits and set policies in terms of how the resources are used. This could be your CPU, your memory, the GPU resources on certain hardware, and so on. And then all the complex operations like how do you configure Active Directory for your Linux containers? How do you configure AAD? Uh, this will all be handled automatically for you. You just specify a setting and that's pretty much it. Same with HA. You just need to say like, okay, I want HA for my SQL managed instance and these are the number of replicas and that is it. We will go set up the HA for you. So this is basically at high level what an administrator can expect out of the platform. Now what about developers? So when you're connecting to your database instance, I mean, it's your usual SQL or Postgres instance running on Linux. You basically do the same thing, right? So this is very important to remember. It's not something totally new. You don't need to learn anything new in terms of how to build applications. It's the same SQL. It's the same PG SQL. Now, in terms of development and tests, however, there are new experiences which are possible. And this is something I will demo later. You can spin up instances in your minutes and seconds. This is something you might be interested in. Same way, you can integrate the workflow of managing your database instances through GitHubs, right? So those are the capabilities. And like I said, like once these services are installed, I mean, you just connect to it from outside. It doesn't really matter. For the SQL, use your existing tools. PG SQL, same thing, right? Now let's drill down into some aspects of security and what it means. So we'll have all these containers up in MCR and we were going to scan these periodically. So it'll go through the build process in terms of, reusing the images across different teams. So these are all things which will be done automatically and I mean, we'll provide that for you. Same way in terms of secure configuration out of the box, we'll reduce and eliminate all the places where you need higher privileges for the containers. Similarly, encryption at rest will be enabled by default where possible, and secure connections will be the norm, right? And if there are certain features which require higher privileges, we'll have an opt to turn it on optionally. And then lastly, isolation of resources, and this is something you can leverage from Kubernetes, and we'll provide capabilities for you to take advantage of those. So encryption at rest. First, for your Kubernetes environment, I mean, this is something you will manage. I mean, here are some examples of how you would do that. And same way for your data controller, we will enable the TDE for the databases by default. And for things like InfluxDB, you would use something like a volume encryption. For managed instance, same thing, just like the managed instance in cloud, we'll have TDE enabled by default. And the other features are existing SQL features which you can leverage. Postgres Hyperscale today doesn't have a TDE support, so in that case you would have to use volume encryption in your storage layer, right? But apart from that, the other features you can use from Postgres. Okay, in terms of security, we'll have basic auth, and this is something which is currently there in preview. And we are going to add Azure Active Directory as an authentication mechanism. This will be offered only in the connected mode, where we can talk to the Azure services. And then we'll have Active Directory as an option. And this is something which we have planned, right? So right now in preview, we have basic auth and the others are coming. Okay, so now let's look at how you would deploy Azure Arc data services in different topologies. So this is just to give you an idea of what it means to use these new capabilities, right? The simplest scenario is a dev or test environment. Say you are on your laptop, you have Minikube running or a single node kubeadm cluster. You can just deploy all of these instances and the control plane on your laptop, right? So that's like the most basic case. The second scenario is you have a small IT department which is kind of managing resources for your Kubernetes cluster, and they can install the data controller in a namespace, and then they can create a namespace per team and then give them access to that namespace. So this is an environment where you have a single administrator for the entire data services, and they can delegate access to different folks and different teams. So this is one way to deploy and use the data services. And then there is another approach where it's completely isolated. Each team gets their own namespaces and an administrator for the data controller, and they're kind of separate. And they can be deployed in the same Kubernetes cluster side by side, isolated, right? So these are kind of ways you can deploy data services and leverage, security policies in your organization. Okay, so with that, let's go and look at some demo. So first I'm going to quickly show you how Azure Arc enabled servers or services look, right? So I'm in the Azure portal here in my resource group, and basically now you can see these new types here, right? It says Azure Arc enable Kubernetes. So this is Kubernetes cluster which is running in my server or lab uh, in my corporate environment, and they are now showing up as a resource here. And these are actually physical. This is a physical server, like a Windows server here, Windows Server 2019, and running in the lab, and that shows up as a resource here. I can take some actions on it. And these are SQL 16 and 17 instances which are running on the server, right? So they show up here too. And down here you have the SQL managed instance running in Azure Arc, and they also show up as a resource here. And same way, like you have your PG instances, your data controller, and so on, right? So this is basically a unified way of seeing different resources, right, in the same place, and you can go define policies on it, and so on. So this is like just quick overview of Azure Arc. Now let's first look at one way to actually deploy Azure Arc data services. So what I have here is Azure Arc, Azure Data Studio. So up here, we now have an option in the connections to do a new deployment, right? Again, this is not anything new. We had this for previously for SQL Server up here, like SQL on Windows, container, or your big data cluster. So now you also see options to install your data controller, right? Which is the first step to using data services. So let's quickly go ahead and click that. So now what it's done is it's looked at my kubeconfig file, and it knows what are the cluster contexts available, and it shows that for me, right? And here the container registry information is needed now because we have a private preview and you need a login and password for that. So you specify that information, and then later you pick what is called a profile, which is basically a setting based on your Kubernetes platform, right? In my case, I have a kubeadm cluster, so I pick this. If you are deploying on OpenShift, you would pick this. If you are doing it on AKS, you can use this and so on, right? So you click next, uh, then you basically fill up the same information like you would do in the Azure, right? So you have your subscription, your resource groups, and down here you have the data controller details, right? And you can provide a password. I mean, these are all same things which you would normally do, and that's it. That's pretty much it. So once you've supplied all these basic parameters, you can click this option, script to notebook. I will actually not execute this because I want to show something else. But this notebook essentially has all the steps needed for you to either automate it, or you can run this and it will go ahead and deploy the data controller onto your Kubernetes cluster, right? So let's close this. Now what I will actually show you is a way to deploy data controller using Kubernetes CLI. So this is just to highlight one option which can be done, right? So before I start describing these, I will go ahead and run some of these uh, because it might take like few seconds. So we'll run that and then I'll come ahead and explain what's happening here. Let's click this. Okay. So the workflow is something like this. It's split into two, I guess, personas. One is the cluster admin who would take certain actions because it's a cluster level operation. And then once these steps are done, you can actually delegate it to a namespace admin. So if you go back to the topologies which I talked about, you can specify a different administrator and they can go ahead and do the rest of the steps, right? So that is what that is, right? So the first thing we will do is basically create a namespace, grant admin rights to it, to the person who's going to deploy the rest of the infrastructure. And then we'll create what is called the custom resource definitions in Kubernetes. And those were the steps I did here, like basically creating the namespace, creating the CRDs. And then later, you as a namespace admin or a cluster administrator can do the additional actions. Again, in these steps, I've kind of split it into different individual actions, but they can all be combined. And some of these steps are not needed when you have the images public, right? For example, this private registry. So here, once the bootstrapper is running, I mean, you can see I've run a kubectl command here. It's up and running here, right? So now we can go ahead and deploy the data controller, right? So the first thing I've done is I've created a secret, a Kubernetes secret, which basically has the username password I will use to connect to the data controller, right? Let's look quickly at the YAML file. It's a very straightforward thing. The main thing to note is basically this part here, right? The username and password. It's encoded, and this is standard way to specify secrets in Kubernetes. And the other step is basically I've created this YAML file with the data controller definition. Let's quickly walk through what that looks like. So this one has the namespace in which the data controller is going to be deployed, some details on where to pull the images, right? Um, and then what services are exposed, the port, the type of service you want to use, whether it's a node port or a load balancer, and then some information pertaining to Azure here, right? And then lastly, the storage aspects, right? So these are things which you can just specify in the YAML file, and that's it. So now at this point, as you can see, I've run this command here. So you started creating the pods specific to the data controller. You can see actually the controller is this, as mentioned, shown here. It's up and running, and you have other containers running. Some containers are actually starting to run, and so on, right? And I've shown the nodes also here just to show like these are getting deployed in different places. This is a 10 node Kubernetes cluster, right? Um, so you can click here. So once this gets going, so this usually takes about three minutes, um, and the data controller will be up and running. And then later, what you can do is you can log in into the data controller and look at the status of the data controller. Uh, you can even do this now, so you can see, okay, what's happening to the data controller. Like it said right now, it's in a deployment stage. You can get properties of the data controller. Again, same thing, but it's right now in the deploying, so it doesn't show it. You can describe the data controller using a Kubernetes command, and this shows all the properties of the data controller, uh, and it also shows like the properties which is specified in the YAML file, right, as shown here. So this is basically a way to monitor your deployment, right? Again, we'll have UI for this. This notebook is just to demonstrate what's happening. Now let's see if it actually completed. Yep, it's almost, yeah, it's done. So it's ready. So here you saw like it basically took about uh, 3 minutes, about 4 minutes, right? So now you have the controller up and running. I can come down. Let's go here. Um, I will log in into the data controller now. So you use this command through AZ data here, right? So this is another CLI, and you can see the status of the data controller. This should show like it's ready. Yep. So there you go. So this was deploying data controller, right? So now let's look at how to deploy the SQL managed instance, right? Same way. So what we'll do is same thing. Here is a YAML file. I go and create it, right? So it started creating. So let's look at how this YAML file looks. So similar to the data controller, you have a secret which basically says what is the SA password and the username, right? Um, so this is the password for the SA account encoded. And then down here you have the properties of the SQL instance, the name of the instance, and here is where you specify the resources. So in this case, I have asked for two vcores and with a limit of 2. So that means this container cannot use more than 2 vcores. And then I can request for different storage, right? So I've asked for 5 gig for my data and 5 gig for my logs. And let's see if it's finished or not. So it's still creating. You can go ahead and do the commands to get the instances. You can see the pod level status, what's happening there, right? So this shows all the container information. So this one takes about like 2 minutes to deploy. So we'll come back to that. So now I want to show you another way to deploy instances. In this example, I am going to use the AZ data CLI, right? So up here in the cell, you can see the create parameters, right? So in this case, you would say AZ data arc postgres server create, right? So that's the command. And then it's got the same parameters like which you saw for the managed instance, and in addition to that, uh, parameters specific to the Postgres hyperscale. So you have the name, cores, memory limit, and so on, right? So let's go ahead and kick off this installation. So what I'm going to do here is create a PG server with 4 workers. So there'll be up to 5 instances in this case. One is the management kind of instance and 4 workers. And each one with about 4 cores limit and 2 cores for the requested vCores. And I specified some memory limits and storage and so on, right? So that's it. So I can kick off this command and it's going to go and deploy the thing, my Postgres instances. So now I can come to say my WSL environment here and we can actually see what's happening. So as you can see, the PG instances are up and running. The SQL instances are actually it's done now. It's deployed. So if we come here, it should say it's ready. Yep, there you go. So it took about like 3 minutes in this case to get the instance up and running, right? And same way, the PG instances are up and running, so they're all done at this point. So let's look at what happened here. So if I come here, yep, it's ready, right? It took about 2 3 minutes to 2 minutes, actually less than that, to deploy. And you saw like how fast it is, right? To deploy, in this case, like 5 PG instances on different, Kubernetes nodes. Like each one is in a different node, and I mean they all got deployed in like seconds, right? Up and running. So this is how fast you can do it, right? So now let's look at what it means to say increase the cores, right? Um, so this is the SQL instance which was already deployed, right? Which we just saw. So what I'm going to do now is I'm going to change some properties of the SQL instance. So remember initially we used like 4 vCores, right? So okay, so what if I want 4 now? I mean 2 before. So now I want 4 and I want to limit it to say 8 now, right? And that's it. So I can save this, quit, and the change has been applied. So now what Kubernetes is going to do is it's going to take the instance, move it to a machine which has the resources needed, like say the 4 vCores, right? And it's going to deploy it. That's pretty much it. So this usually takes like about few seconds. We can come here and manage here too. As you saw here, in this case, it's in the same node because there are enough resources available. So it didn't actually move it, but it's restarting the container, right? You can see here only the 2 containers are ready in this pod. So there are 3 containers which need to be ready. And this will take about like 2 minutes to get up and running. So this is one way to actually increase the resources for your instance and do it in a very easy and seamless manner, right? The same capability will be available through the AZ data command line also, right? You can do the same thing using edit. I will not do it, but I'll just show you the parameters. Same thing. So you give a name, you say how many cores you want now, what is the limit, same for memory, and there it goes. It'll go and go deploy. Okay, so now it's done. So at this point, it didn't move the uh, pod from this node, but it increased the resources, right? So how can you confirm that? So let's come here. So here is where I was before in the describe, and let's click here. right? So it's all up and ready. And if you come to the container here, so now you would see here. So this is my SQL container, right? And now the limit is set to 8 and request is 4. So this is actually how easy it is for you to deploy instances, right? How fast and how extensible the platform is, right? Now I'll show you another cool way to deal with this, right? Okay, so here I'm going to use a workflow which is basically integrated through GitHubs, right? Uh, I'll kick this off so it starts running, and then I'll explain what's going on here. So what we have here is for the GitOps workflow to work, you first need to connect your Kubernetes cluster to Azure, right? Which is done through this AZ command. I've done this already. It takes some time, so I didn't want to wait. Um, so so that operation is done, right? So once the cluster is connected to the Azure environment, which is what I showed in the portal a while back, then you can go ahead and enable the GitOps configuration, right? What that means is we deploy an operator called Flux, and this essentially can get changes from a Git repo and apply them to your Kubernetes cluster, right? So that is the workflow it enables, right? So that means you submit a pull request here for an instance, like say you creating a new instance or changing a property, and they will automatically get pulled and applied to your Kubernetes cluster. So this is a very powerful way to manage your instances, your environment, as if it was code, right? I mean, this is very critical. This way you can audit what's happening, who's doing it. You can review the changes, right? Just like code. Same thing here. So the way you enable it is once you have a connected Kubernetes cluster, you create a configuration, and to that configuration you would specify your Git repo, right? So this is the repo here. Let's look at what it has. It's a very simple one. All I have is one file here, which is basically the SQL instance, right? It's this one here. And the SQL instance, I've named it this way. I've asked for 2 cores and limit, same thing, storage 100 gig and 5 gig in this case, right? So let's see if actually the cluster configuration is done, right? Should be done here. Yeah, so it's running. Those operators are all running. So now SQL is already running. So what this workflow has done is taken this YAML file up here, right? And then it's applied it to my Kubernetes cluster. So this is the SQL instance which I deployed a while back, right? We're using the Kubernetes CLI. And this one got deployed just now using GitOps, right? So now imagine I am a developer and I'm developing another my HR app and I want another SQL instance, right? So here I have a YAML file where I've created another spec for a SQL instance. I want to call my instance SQL my HR app. For this I want more vcores, right? So what I'm going to do is create this, right? That's it. So now I've committed this file, right? So this YAML file for my SQL instance is up here. So now if I come here, within a minute what will happen is the operator which is running in your Kubernetes cluster is going to pick up that YAML file definition and it's going to apply it. So there you go. So now you saw this instance it's creating, and the instance will be up and running in few minutes, right? So we can come here and check where it's there. Yep, there you go. It's almost up and running, right? So two containers are up, two more, one container is still running. So as shown here, right? So I don't know about you, this is actually pretty cool, right? Uh, I mean, I have like many Kubernetes clusters where I deploy, different builds and I try different scripts. Now I can manage all of this through my Git repo, right? I can create a project, set up my YAML file for my instances, for my data controller, everything. And I can just check in code and I don't need to do anything. I mean, this operator is sitting there and it's just deploying, these changes as it comes through, right? And again, somebody can review these changes for me and yeah, this is how you would do code, and that's the same thing we are doing here, right? So this is actually a new way, and hopefully this gives you idea of how you can leverage these new capabilities this platform provides and deploy and manage these instances, right? So with that, let's get back to the presentation, right? Okay, the last thing I want to actually show you is HA capabilities, right? So we call this like built-in HA when you deploy data services. The first one is what we call standard HA. So this is what you get by default with a single SQL managed instance. Um, and this is backed by persistent volumes, which is essentially the storage for your SQL instances. And in this case, we recommend basically using remote storage. So this protects against, restarts of this node, and in which case the instance will be automatically moved to another Kubernetes node. Um, Say somebody accidentally deleted the pod running your SQL instance, it can get recreated again, right? So this is basically standard HA. In this case, the failover time can be like up to minutes, right? So that's standard HA. And then we'll have what is called like premium HA, right? In this case, you will have multiple SQL instances in an availability group. Again, this is something you would just specify as a simple parameter in the CLI, and that's it. It will automatically be enabled for you. This is similar to what happens in the PaaS offering, right? If you install SQL DB or if you create a SQL managed instance, I mean, you just get HA. You don't need to think about it, right? Same thing here. So let's look at how standard HA works. So in this case, basically what I have here is I have a SQL managed instance here, just like one of the pods shown. And this one has some request to a persistent volume, right? Which is remote, meaning it's not on the same node, right? And you have your applications which are connecting through a service and talking to that, right? So now imagine if this Kubernetes node goes down. Uh, you have an update which restarted the node, or you took it down for adding more memory, right? So now what will happen is the pod from this node or the pods will be moved to other nodes. The same thing happens for the SQL instance, right? It gets moved to another node, and then the persistent volume is attached from the other node. And then the service gets automatically redirected to this node. So for your application, there'll be some downtime and then it just simply reconnects, right? You didn't need to take any other action as an administrator. I mean, you can turn off the node, simply power down, and the apps and services will just move, right? So this is built-in capability, HA capability provided by Kubernetes, right? For any pods running in Kubernetes. And this can be leveraged out of the box, right? Then you have the premium HA, right? So this, as I said, it leverages the always on availability groups, right? We will set it up with 3 sync replicas by default, right? And you will now have both a primary and a secondary endpoint, right? So the primary endpoint is used to do all the write operations, right? So any application which wants to commit data to the database instance will use this service. And then for your reporting app, which want to just do read-only queries, you would go through the secondary service, right? So that's what is shown here, right? So here is your reporting app talking to your secondaries. And this is your app which is generating the transactions out here. Now imagine in this scenario your primary files, right? So what will happen is we will automatically promote one of the secondaries to primary, right? Which is what happened here. The service will get redirected automatically. The secondary will come up on the same node or a different node, it doesn't matter. Similarly, the service here, which is pointing to the secondaries, will automatically get redirected to the new secondary, right? And that's it. Everything continues to function. In this case, it's the failover is really seconds, right? Because your other instances are already up and running. They are sync replicas. The transactions are already committed there. They can quickly switch over, right? So let's look at how this looks in the demo. So for this one, I am actually going to use a, the big data cluster environment. So right now we don't have the Kubernetes HA ability implemented yet in the Azure Arc data services, but this kind of shows you how it looks. So we'll use that here. So in this case, imagine these three instances. These are SQL instances actually. They are your managed instance, right? So three replicas, 1, 2, and 3 out here, right? Let's increase the font a little, right? So first, let me show you here how it looks. So I have connected to the SQL instance in ssms, right? And you can now see this availability group. It's already deployed. It's at the time of create. You just need to say you want HA, and these are automatically created for you, right? Um, and you can see in this case now the primary instance is your master 0. The secondaries are up and running. They are everything is fully synchronized, right? I can come here, do a query, right? Sorry, server name. Yep, so you can see I am connected to the master 0 here, right? It's all up and running. So now let's simulate a failure, right? So what I'm going to do here is go to the pod here. So let's see here, right? So this is all the things here, right? So we know that the primary is master 0, right? Based on that report. So what I'm going to do is just simply delete that pod. So the delete operation in Kubernetes, I mean, it's not like your SQL delete, like where the data disappears. You are basically deleting the instance of your application, in this case the pod, from that node. So what will happen is Kubernetes will just take the pod and create it in some other machine, right? Or it could be run the same machine. So now if I come here, like this thing is basically it's going to refresh, right? It's on, and as you saw the node change, right? So before it was master 0 and now the primary. So I can come here and I connect. Now it's master 1, right? So it was literally order of seconds. So the secondary, the new secondary, which was basically a primary before, it's now synchronizing, right? It's going to start soon. And you can see here the pod is also up and running. There is one more container which needs to start, right? And the other secondary started synchronizing, and this is gonna start going. And this is like your typical HA operation, right? So in this case, like say, imagine the same failure happened, like basically you took down the node for maintenance reasons, or the node just died, right? Um, so the pod will automatically get moved to a different machine, and the HA operation will take care of the failover for you, right? In this case, the AG synchronization happens automatically for you. You don't need to take any other action, right? So now the same thing you can do for the regular or the standard HA, right? So remember the same SQL instances which we deployed earlier. Um, so if you see here, like I have this guy here, A3, right? So let's do the same delete there, right? SQL test 1 dash 0, right? Again, so this is like restarting your SQL instance, right? Um, and Kubernetes will automatically create the pod again. It'll restart all the containers, and that's what happened here, right? The two containers are already up and running. The third container is going to start soon, and that's it. In this case, it didn't have to move the pod because the node was still available, and it's faster to bring up the process on the same machine, right? And that's what happened here. And this will take like about few seconds, and it'll be up and running. So these are some capabilities which Kubernetes provides by default. And then in the case of the premium HA, we leverage the always on availability groups, right? And you can basically get the same experience, right? So here now your secondaries are synchronized and they're up and running, right? And this one should also be up and running in another few seconds. So this kind of shows like how HA works in this new environment. From an end user perspective, it's really the same, right? In the sense your experience is the same. So yeah, there you go. So it's this one is also up and running, right? So that was a quick intro on like how HA works, right? And, and with that, we come to an end of this presentation. So hopefully you got an idea of what Azure Arc Data Services is, what are the various deployment options, some new ways to manage resources, create these instances. I showed you a way to treat these instances and your environment as if it were code, right? Um, so you can deploy your instances with your code changes and propagate them in a very automated fashion, right? Um, so these are new workflows which you can leverage. You can see these resources up in the portal. You can leverage the Azure control plane capabilities. You can leverage policies. So these are all new things which you can do. And we hope you try it out. And here are some resources. And let us know what you think. The first one points to the Azure Arc data, like what it means, some videos and so on. The second one is the documentation link, which will be up and running soon. And the third one is a GitHub, which has what we call jumpstart kits, which can be used to deploy the Azure Arc Data Services in different Kubernetes environments, right? Doesn't matter if it's AKS, if it is Amazon Kubernetes, Google, doesn't matter, VMware. So we have templates and scripts there which you can use, customize and deploy, right? Thank you so much for listening to me, and please feel free to send us your feedback. With that, we come to an end. Thank you.